Okay, I want to start with what LiveView Native is not. And this is not a knock against other efforts that are out there, but it is not a web view. It is a purely native implementation. And it's not a unified UI. So one of the kind of comparable examples out there, or something else that's in that space, is of course React Native. And React Native has that one kind of UI experience. You build it once and it plays everywhere. My personal experience of doing that on native devices is that the user experience always feels a bit compromised in some way. The way that users want to use a particular mobile device or a particular native device kind of has this like language to it over time, and kind of having this similar experience across devices tends to be a bit disjarring. There is value to brands wanting to be on brand across all their application experiences. But as far as compromising on the actual user experience is something that we've decided to go in a different direction. So as I said, it's 100% on-device native user interface. We use the actual native UI components of the particular target device. So in Swift UI, we're using all the Swift UI components. On Android, some may not be aware, but there's a new Android UI framework called Jetpack Compose. We're using those components. And you write your LiveView native applications in the exact same way that you're currently writing your LiveView web applications. Didn't require any asterisks. Upstream changes to LiveView in Phoenix. I say that with an asterisk. I think there may have been like one slight tweak, but it was probably more of a convenience than like a show-stopping type thing. We wanted to make sure that this was not going to be something that required significant changes on the Phoenix side of the tech. So we've seen multiple instances over the years of teams that love Elixir, they love Phoenix, and they're really loving LiveView, but they, the business demands that they have to be in more than just web. They need native applications. They need to be on desktop. And right now, Elixir did not have an answer for that. So they would reach for React Native. They would stand up a Swift team or inject a C team. And these mean that there are higher operational costs for companies. Anytime you have cross-disciplinary teams, we can't really, as engineers, we can't jump between the technologies as easily as we used to. There was the idea of the full stack engineer, or the jack of all trades, and this concept is kind of dying off. There's more speciality that exists today. I hope to never swap out of Elixir at this point. And this isn't like just an attempt to just apply Elixir everywhere. I think that what you'll see, and as the LiveView Native project evolves, is that the same benefits on development time that we're seeing with LiveView on the web will translate over very easily to native. React, so I think a lot of technologies tend to, technology like ecosystems right now tend to want to play nice with one another. They don't want to, not necessarily like poo-poo on the other technology, but there's this real reluctance to define what makes something good and why it doesn't do what the other things do. And I go the opposite way. I'll say like why we should be doing this, why we shouldn't be doing that. And React has kind of, not by design, probably just by opportunity, taken advantage of this, and they've started to eat up the ecosystem by and large. Most of the native mobile shops that I've known over my career have almost exclusively all gone over to React Native. So React has web, React Native has mobile, and now there's a React server implementation as well, built by Ryan Florence. He's a pretty good guy. He built React Router. But what we're looking at is a potential competitive threat to Phoenix and most other web technologies, because if you can have a React engineer work on web, work on server, work on native, then that's your team right there. We've had many clients come in over the years that want to use Phoenix as just an API, and they want to use React on the front end, and they're like, oh, they want to use React Native, and like, oh, we're using React Native, we don't need LiveView, we want to use React on the web because we have React engineers. So we need an answer to this. This expands Elixir's utility. As I spoke about a few minutes ago, moving Elixir and evolving it beyond just being a web technology, I think is going to be really critical for the longevity of the language. And so when I left DockYard, DockYard has always been a web consultancy. We started as a Rails shop, moved over to Ember, and then Phoenix. And I had a product company I wanted to start, and then COVID happened. And so the product company was, I won't go into it, but it required me to be interfacing with people directly all the time, and that wasn't something I was willing to do. And so I started thinking, like, all right, I'm really bored. What else can I do? I love going to the movies. And so movie theaters are being decimated. I came up with this idea that, what if we can improve the experience of drive-in theaters? We started seeing drive-in theaters starting to pop up because you're in your car. It's fairly isolated. But the problem with drive-in theaters is that they are contractually not allowed to run what are called first-run films. Mostly because it's so easy to pirate a movie from a drive-in theater. And in addition to that, movie studios really want to have a higher fidelity experience, whether it's the audio or visual systems, that their content is being shown. And most drive-in theaters will have something over like an AM or local broadcast kind of mono channel. So I started thinking, okay, Elixir's has a background in telephony, or Erlang has a background in telephony. Is there something we can do here? And we started to explore it. And I pulled in Elle, I pulled in Chris. We built up a kind of a cool prototype where we used VLC, and VLC would broadcast over Phoenix channels, and then you had a mobile application that synchronized the audio stream in your car. It was within something like 100 milliseconds, and it worked perfectly. It was really, really cool, but selling into a movie theater like business is a mind-numbing experience, and just wasn't going to happen. Suffice to say, we brought in a mobile engineer, and some of what was happening at the time is that SwiftUI as a framework was starting to come about. We didn't end up building that application in SwiftUI, but we experimented with it a little bit, and this was early 2020, or like mid-2020, and so LiveView was probably like 6 months, less than a year at that point, I believe. But SwiftUI as a framework is composable, and so it started like, little potential, seemed like, oh, this seems like something can be done here. The project went away, but the idea did not. So over the next year or so, I kind of had the thought in my head, and I would ping Chris every now and then and say, what do you think? And Chris is like, I'm trying to make a baby, leave me alone. And so he, but finally, I think I got his attention, and his brother, I believe, is in the native application development space, and so he spoke with him a little bit, and the idea started to resonate with Chris, and we explored this space to see, what is this even possible? What we found was that someone back in 2016 or 2017 had used a this feature within Swift called Codable. And Codable is just a protocol that allows you to kind of transpose like one format over to another. They took a JSON object, a JSON document, and were able to update the key value pairs in the JSON document, and these key value pairs translated directly back to SwiftUI components. And so that was enough for me to say, oh, that's interesting. You know, maybe that's the direction we can go in. But we wanted to try to do it with XML documents because we did not want to blow up how you're building LiveView templates. And it was just going to be a much more natural fit. So Swift does not, out of the box, have a Codable protocol implemented for XML. I found one and started to play with it. Wasn't really working. So I reached out to the creator of the library, this guy Max Desiatov. And by chance, this was like the perfect person to talk to. Because Max, I believe is over in London, he is currently reverse engineering SwiftUI. So SwiftUI is a closed source project. Swift as a language is open source, but SwiftUI is closed source. So we don't really know what's happening under the hood. And Max is trying to reverse engineer SwiftUI and compile it to WebAssembly. So I'm like, oh, we're doing a WebAssembly thing. You know, let's talk about that for a bit, and kind of transition the conversation over to what would eventually become LiveView Native. And he pointed out and said, no, you don't want to go with the Codable protocol. It's too slow. What you want to do is maybe just build up a VDOM and walk it and instantiate the components from that. And so that's the direction that we ended up going in. So what I'm going to bring you through right now is a very basic implementation of LiveView Native. It's actually a re-implementation of my proof of concept that I built out, which is just displaying numbers on screen. So we have a simple LiveView application here. It is just every second it will send a new update and just increment the counter, and we display that counter on screen. So here's our, I'll show the, not that we need to see the web version of it, but I just want to show the transition from web to native. So here's the web implementation, the LiveView template, span with just a counter variable in there, and then count it up, okay. So let's bring in now the Swift side of things. So we have a full tutorial on the site I'll be going through in a little bit, but just to kind of bring you through the process here, we're creating a new iOS application. We make sure that the interface is SwiftUI, the language is Swift. We want to add packages. The URL, we'll get it all out there later, but this is the URL to the the LiveView Native client. We add it in. And then inside, kind of like the root of the application in a Swift app is called Content View. And it comes with like when you generate a new Swift project, it comes with some code in there already. So we remove all that, and we just make the content view look like this. We create our LiveView coordinator. We point it at the endpoint of our LiveView application. In this case, I made the endpoint the root. And then inside the body, our view component, we put in the LiveView component. And then that's it. So back on the Phoenix side, we're going to change these span elements over to text ones. So text is a SwiftUI component type, and we are going for one-to-one parity. So you can go and look at the SwiftUI documentation, find a component on there, and through our naming convention, we are implementing the same exact, we will be supporting the use of those components through this naming convention. So for example, text is capital T text, in our LiveView Native template it would be lowercase text. If something is camel-cased in LiveView Native template, it'll be hyphenated. So we just go and change this over to text. We go and press the play button to start the simulator. Wait 45 minutes for the simulator to launch. It comes up. and it is counting up. So it's a actual LiveView, it's an actual native SwiftUI application. Not too impressive as a simple counter, but so when I got that working originally, I think Chris had just had his son. I was trying very hard not to bother him on his paternity leave. I was like, look at this, look at this, look at this. Okay, so let's, but does it scale, right? Is it performant? Let's see. And this is where I don't know what's going to come over, between the refresh rate of the video, the refresh rate of the monitors, and then on the streaming. But we're going to change it from every second to 1 millisecond. The updates will happen every 1 millisecond. So keep in mind, what this would be doing is updating and re-rendering the LiveView template server side, pushing that, the minimal amount of diff over the wire over to the LiveView Native client, and then we'd be instantiating and integrating into the SwiftUI view tree these updates. Oh, hold on. My video not play? Oh, there it goes. Okay, so I can't really see if it's just looking like a blur. But we're going to. Oh, I got this monitor here. Okay, so what we're doing right now is I'm showing that you can actually back run the application. It pauses the connection, and then when you bring it back up, it reestablishes connection. So it's working and bring itself back up the way a LiveView application is expected to. Okay, so let's keep expanding the functionality here. A counter is not going to impress your boss. All right, so we want to add some functionality. We're going to increment, comment out, our timeout, and our send afters, and we're going to handle incoming events. I don't know why I have 2 there. I shouldn't have 2. One of them matches though, so it works. So we're going to take our original LiveView Native template here, and we're going to add a button. Button, again, SwiftUI component. It will respond to the Phoenix click event. Notice we're using the exact same naming conventions and the exact same Phoenix events that the LiveView web applications are going to use. So we are trying to stay in that lane as much as possible. If you are used to writing a LiveView web application, other than the whole nightmare provisioning applications and stuff for App Store, building a LiveView native application should come very naturally to you. Uh-oh, what's going on there? All right, so SwiftUI as a web rendering frame, it's when you render these components, it doesn't do what like web does. It doesn't try to reflow the elements to avoid one another. So we need to add a little bit more to our template. And I'll just go horizontal, just for screen space. Sorry, Jim, I'm kind of encroaching on your nice little template there with all this stuff on the right-hand side. And we're going to use what's called a VStack. VStack allows us to vertically stack components, and they will respect each other's kind of boundaries. So we come up and we press the button, and now it's doing exactly what you would expect it to do on the web. Let's add a decrement counter. So we handle the decrement event, and we're going to, we wrap it in H-stack so the buttons are next to each other instead of vertically stacked. And we can add and then subtract. Very basic, simple stuff. But these don't look too good. They look like they're kind of basic, so we need to style. And in SwiftUI, styling is done through a system called modifiers. Modifiers just the instance of the component. You can, it will just return itself, but every time you call a modifier on it, it will just restyle on whatever the modification is that you're trying to do. So in this case, we are doing, in all these things, these are not LiveView native like things here. Like our implementation of it is, but the actual naming of them, you can go and look at the SwiftUI documentation. If you need something, that's where you go. So we are using a modifier called button style, and we're setting it to what is called border prominent. And then the tint is teal for the increment, and then red for the decrement. And then we get these nicer looking buttons right there, and they're functional. Okay. Something else that I think is pretty cool is, I joked about the simulator taking a while to launch, but just to kind of show what we're actually able to add for developer ergonomics here with LiveView Native is, you may need to restart the simulator when you're building SwiftUI applications if you change something. If you're using the preview, sometimes not. But what we have is we've implemented the Live Reconnect as well. So I think you can't see like the little progress indicator there. I think it's moving forward. Is it? I think what we're waiting on right now is just, I'm trying to show it's taking like 7 seconds to launch the simulator. Can't tell if the video is running. Oh, okay, there it goes. All right, so I press the button, we're waiting. Okay, now it's up. But we don't have to redo that on every single time we make any type of template changes. So we actually listen for those re-render events, and we're going to just add in some basic text here. And as soon as we save it and go back to the simulator, boom, it's automatically there. So we hope to implement more and more nice developer ergonomics to not just subject you to like kind of we have all these nice tools on the web to build stuff, but when you move over to native side, you can sometimes lose this. We want to try to bring everything that we can across. So we want to leverage everything that exists in the device specifics, the specific devices developer tools for native. That is, whatever the UI frameworks are on that specific platform, that's where you're going to go and find. Like, we're not done implementing all the components for Swift, and we're much farther behind on Android. But as we continue to make progress, we're going to be in a position where we've been able to do essentially a lot less work than was necessary to build up React Native or a similarly transpiled type solution, because we are leveraging a lot of stuff that already exists, and we're just building the client. We're just building kind of like that middle between the two. And I want to be clear, this is not LiveView Native or nothing, meaning that if you build a LiveView Native application, you can integrate it into an existing SwiftUI application. LiveView is just another component in the SwiftUI view tree. So for example, here is our content view that I showed that we generated and we dropped in the LiveView component. And so what I'm going to do here is I added a few other components that are just purely SwiftUI components. So we added VStack, we add the text, and then Spacer is this component that will essentially create as much white space as the viewport allows without pushing the elements on either side of the spacer off the screen. So we have a mix of actual SwiftUI native components and then LiveView serving up and creating its own native components on screen. So if you have an existing SwiftUI application and eventually a Jetpack Compose application, and you want to integrate LiveView, it doesn't have to be this fork in the road. You can say part of the application, we can keep what we've already done, and we just can add these other parts into LiveView Native. It's a major value add for companies. All right, so let's take a step back and kind of talk about how we were able to accomplish this and specifically what's going on. So I want to reiterate, it's not a web view. So as I said before, LiveView Native sits in the middle. And LiveView and Phoenix are just doing exactly what it's always been doing for LiveView applications. And then on the native side of things, in this case Swift, because that's the first one we implemented, is responsible for providing a component library. It's responsible for its own view tree. It's responsible for all the rendering and all the stuff that it normally do. We're trying to minimize the amount of work that we can do, or that we need to do. So the way that the LiveView native client works is it will first, through that connector, it will first do an HTTP request, or an HTTPS, whichever URL scheme you provide it. It will grab the dead render view of the page. For those that are unaware, the dead render view is just a regular static server-side rendered template of the page. And LiveView does a double render. It will render out first what comes from the server, and then it will re-render the page in LiveView. And you don't notice it. It happens so fast, and it's transparent, but a double render does occur. And that, when the double render happens, now you're in the LiveView kind of state for the web page. But we do a very similar life cycle. We grab the dead view, and then we go and the dead render, sorry, and then we go and we parse out the LiveView document in it, the fragment inside the larger document. This becomes what is effectively our virtual DOM that we're holding in memory. We parse it with whatever like markup parsing library is available on a specific device. On Swift, it's called SwiftSoup. And we then go and establish a LiveView connection. So thankfully, a lot of this work was already done. There is already an existing Phoenix channels client for Swift. We were able to use that. We had to make some changes on it because it was not accounting for changes that were made to the Phoenix channels JS client that were made on behalf of LiveView. So we were able to get some updates in order to align it with what we were needing. And then we walk that VDOM and we look up in a registry system. So we support not just all the SwiftUI components, but also creating your own custom components. So I'm hoping that there will eventually be an ecosystem where you can create LiveView native components to distribute and share with people, and they can just drop them into their applications and be even faster about building them. Then they just reference them back in their LiveView templates. So we walk that virtual DOM, and whatever the element name is, we then just do, I actually don't remember if it's a key value lookup, but basically we were able to, through the registry system, say, oh, this is a text element. We know that this corresponds to the text SwiftUI component, and then we instantiate it. I think we actually do a depth first, and so we work our way back up to properly build up that view tree. And then we hand off that built kind of component view tree off to SwiftUI, and then I have no idea what happens at that point. It's black box. I would love to know, but again, it's kind of the nature of working in this space sometimes. It can be a bit disconcerting as an open source developer, not really knowing and just trusting it. But the nice thing is that a lot of this stuff has just worked. So one of the early challenges that Chris had with LiveView was managing like cursor position within an input element. And I'm sure it's buried somewhere in the LiveView code, but they had to account for that. So when an update happened in the template, it got rendered in, you can imagine that input element may be wiped away, and the content in that input element may be wiped away, and then re-rendered on screen, you lose your position or even the content that's inside the input element. And I was concerned that this was going to be a problem for SwiftUI, but it just worked. We rendered an input element. I put the cursor position right in the middle of the word, and then re-rendered, did some changes to trigger a re-render of the view tree, and it held its state perfectly. So there's a lot of nice things we're getting for free from SwiftUI, and it seems to also, I believe this is consistent on Jetpack Compose as well. But again, it can be a bit disconcerting not really knowing what's happening under the hood. And I'm sure there's a lot of optimizations that we will learn about and be able to improve over time as we work more in this space. So as the patches come in, we as the diffs come in, we patch the VDOM, and then we just go right back to step 5. We rewalk that VDOM, instantiate a new mini view tree, and then we push it into the SwiftUI view tree. And this all happens within microseconds. So you saw an iOS kind of example. The nice thing here is that we can not just target iOS with LiveView Native. We can also target macOS. We can build desktop applications with this, native desktop apps. We can build tvOS applications with this. We can build watchOS applications. And anywhere else, Apple and Google decide that their native frameworks will be deployable and can target. So this dramatically expands the potential and application of Elixir and Phoenix and LiveView. And to kind of bring that point home, it's not just SwiftUI. We started with Swift because I have all Apple stuff, and that's just what I felt like implementing the first pass in. But we have been implemented our kind of I believe the morphed on version in Kotlin and the client in Kotlin. And now we're going through the process. Kotlin is the replacement language for Java on Android. And now we're going through the process of tying in Jetpack Compose into it. So I think we're like maybe 3 to 4 months behind where the Swift client is currently at. So we have Android Jetpack Compose. I want to build a Windows client as well. So WinUI 3, for those that are unfamiliar or have on purpose tried to stay far away from Windows as possible, I'm one of you. I spent some time looking into this, and WinUI 3 appears to be just an XML-based document for building up UI, which is perfect for us. So it's composable. We should be able to adapt to it pretty easily. This one is more of a I would love to have it. So there is a Phoenix C# client, and I spoke to the creator of that, and he made it for Unity. What I think would be sick is if we had games out there and their scoreboards and all their UI is being served up by LiveView Native, and it's totally doable. In addition to that, question mark, what else can you dream up? I don't want to overpromise and make it seem like we can just start throwing LiveView at everything, but it's starting to feel that way to a degree. And I don't know if this perfectly aligns with his vision, but I remember years ago I saw a talk by Dave Thomas, and he spoke about this kind of concept he had, as channels were coming out. I think this was pre-LiveView even. I forget. Everything pre-COVID kind of just mashes together. But he kind of gave this example as how he would walk into a coffee shop, he'd sit down and look at the menu, a digital menu, and then he'd look at his phone and watch, and everything was just these UIs are being served up by a Phoenix server. And I think that this is starting to maybe realize that vision to a degree. Now, whether it perfectly aligns with what Dave was talking about, I don't know. I haven't spoken to him about this, but it does feel like we have the potential as a community to vastly expand how and where we are using Elixir and applying it, and get all the nice and easy ways, basically speed up the development, make it a lot easier to build and support these applications. And I mean, I spent some time building out just Swift applications early on the prototyping just to familiarize myself with it. Doing all that network stuff is the same pain in the butt as it is without LiveView. You have to account for all these edge cases that exist. And with LiveView, we get all that stuff is no longer a concern for us. We just care about building the templates. We care about hooking things up properly. We don't have to care about all the kind of underlying edge case problems. Chris does. We don't. So as you can see, potentially this has can vastly expand pretty quickly if enough time and effort was put behind it. And to me, that starts to feel a bit unwieldy, things maybe get out of control. Maybe some of these clients just become unsupported and no longer, it'd be great if there was a Unity client, and maybe that person moves on and we lose it. And so I tend to think of like, how can we optimize that? And so the LiveView clients on Swift, there's really kind of two sides to it. There is what is essentially just the morph-dom kind of re-implementation of merging in the patches. And then there is the LiveView client side, where it's connecting to and handling the requests and the event handlers and all that. I think that we could potentially commoditize that into either a Rust or a C library. And that way, whatever type of native target you want to look at, you have like maybe 90% of the work already done. You can just pull in those libraries and just wrap them and build out, start attaching them to the proper, whatever UI components are available for that target. So I'm hoping that sometime in the next year or so we can start to do that, because I start to think about just the cost of maintaining and building out all these separate efforts. And any way we can kind of consolidate that under one effort, I am in favor of. So when can you start playing with this? Right now. So go to GitHub/LiveView Native, and there is the Swift client repo on there. If you go into the README, there'll be a link to the tutorial. It can walk you through building your first LiveView Native application. There's a lot more to it. It's not just like the little counter thing. You are bringing in asynchronous images. You have navigation and resorting and some button stuff. We had so one of the next, hopefully very soon we'll get this back in. We had animations in for a period. So like the hero animation, like you have like the list view and then the image of something and you tap it and then it carries that image through and grows it over the next screen. That was working, except for like 1 or 2 bugs, and so we decided to pull it out for this because we didn't want to show something that was too buggy. But that will hopefully be back in soon. And then I have a Shyamalan Twist for everyone. So yesterday, around like 4 or 5 p.m., everyone got an email about an application, a chat application, to use for the conference. This application right here, and this is a LiveView Native application. So it went out a little late because we didn't get App Store approval until 9 a.m. yesterday morning. But cool thing with this is that we open sourced the project, so it's on the LiveView Native organization. We have the rest of today, we have tomorrow. The chat application, it's either very limited in function because I decided to do that, or we didn't have enough time. So you decide which one it is. But anyway, there's a lot of cool things we can add in. Make pull requests. We will deploy your pull requests if they are reasonable and fun, and we will get it up into the application. We're going to take down the chat app at the end of the conference, so it's gone after that, unless Jim wants it back next year. But we'll start to play with this. You don't have to do any Swift UI coding. It's going to be all in the Elixir application, all in the Phoenix app. So pull it down. If anyone does a pull request that looks cool, we will deploy it, and it'll be inside the application before the end of the conference. So I want to recognize those that have really made this project possible. First is Anil. He came to us through Chris. I think he made I forget exactly the background, but I think he helped Chris with something on maybe the Live Beats demo. But anyway, he has that nice kind of cross knowledge between Swift and Elixir, and he's also just going to a sophomore year of college. So it's pretty awesome that he's that good at that age. But as I say, he's going back into college, so he's only going to be available to us part-time. So we're looking to definitely find more people that have Swift knowledge, that have Phoenix knowledge, Elixir, LiveView knowledge, that are interested in this project. Also, May, she's over here somewhere, hands up. And I'm jealous because she has probably the coolest GitHub handle that's out there. And I think it's only been at DockYard for maybe 3 or 4 months at this point, and pretty early on she said, I'm interested in this, I want to help. And so she came in and really helped us get the chat application done over the past week. I think that in all, the chat app was probably really only maybe a day or two of work, and like most of the other work around it was just adding in things and fixing things in the LiveView Native client that we didn't realize or overlooked. And then of course, Chris has made himself available for answering questions and supporting the project, and also allowing us to call it LiveView Native, which is also very helpful. And then finally, Daniel Reese, who is the maintainer of the Swift Phoenix Channels client and the creator of the Kotlin Android Phoenix Channels client. So he's been super helpful, especially we haven't really had to bug him too much recently because he fixed the problems that we needed fixed early on, and they've just worked. So I want to thank him for that time that he's provided to us. So just some, I want to be very careful in setting expectations. I don't like to do that because I've been bitten too many times. But I will say that I hope that we can cover most, if not all, of the Swift UI components by end of year. We'll see. We have to do some cleanup on the project. You guys, as you can imagine, rushing to the conference, we had to just get things done as opposed to get things done the right way. So we'll take a little bit of time, and we'll go back and get the project all tidied up, and then we're hoping to just, at that point, it's just grunt work, just adding in more components and getting them in there. I'm hoping the Android Jetpack client will be roughly 50%-ish done by end of year, and we want to hire a Windows UI 3 engineer to start implementing the Windows client. So if anyone has WinUI 3 experience, come and talk. Or even better, if you just want to do it for free, that would be awesome. Okay, so why is that there again? Services offered. I guess I just threw this in there. Okay, so yeah, staff augmentation, we build your product, and white glove services, just as a reminder, DockYard.com. And finally, as mentioned earlier, we are hosting a drink event tonight. I think, is it 8:30? I don't know the time. People just tell me where to go, and I just show up at things. So I'm like a child, I get led around by my hand. But I wanted to say that if anybody out there is a sailor, I race sailboats, and I would love to talk with you. There's actually some cool stuff we're doing at DockYard regarding sailboat technology in Elixir. So thank you very much.